Hello learners, welcome to the today's topic, that is mining complex type of data. Myself Priyanka Gupta. I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. I am going to cover the topics today. I'll cover mining complex data. What is complex data? I'll tell about. What is multidimensional analysis? I'll tell about descriptive mining of complex data objects. What are the data objects and how the complex data objects we are going to mine. The generalization of structured data. In that we will cover the spatial and multimedia data. And I'll also cover the aggregation and approximation of that with example. Mining complex data. So what is complex data? So that data that is difficult to handle, that is in huge amount, that is a complex data. And if we are going to mine that data in data mining, so that is called as a mining complex data. So in a traditional data mining, what is in a conventional data mining we were using, that is only focuses on examples given in a relatively simple attribute. So that will having the simple attribute format, one format for there. That means that every example having a specific value. So every example were having the specific value structured format, and that was having the specific value for each of the possible attribute. So that were in the traditional data mining we were using. If we are having the huge amount of data, if we are having the larger amount of data, so in that the various forms of data will be there. That we have seen in earlier our classes, that we are having the structured data, we are having the unstructured data, we are having the multimedia data, audio data, video data. So that is nowadays that is growing very fast. So because of the use of the we are having the mobile, we are having the web users. So because of that, that is growing explosively, and that owing the rapid progress in the data everywhere. So we have to work on that data, how to collect that data. We are having the data collection tools, we are having the advanced database system to store that. Some technology is there how to store that. Some relational database systems are there. Some data warehouses are there for business analytics purpose, and as well as the www, the web wide web technologies are there to capture that data, to store that data. So that is an increasingly important task to store that data to process for the data mining, that type of complex data. So complex type of data, including the complex objects, data objects, that is having the spatial data. Spatial data is nothing but that data that is having the geographical images. The data that is multimedia data. Multimedia data is having the video and audio files, and as well as the time series data. The data that has been stored in the form of time format over the time, that in the months, in the year, and the we can say in the day. So the data that is having the text data, and the data that is over the World Wide Web, that is the Google. So all type of data that has been in work, that is called as a complex data. So we need to develop some of the data mining techniques to do the data mining things. So what are the techniques are? The technique is characterization, association, classification, and clustering. So in that we have already covered the classification and clustering. So we will have a view about what is characterization and associations, and on that we how to develop that new ones to cope up with that complex type of data, and as well as to perform the fruitful knowledge, fruitful information mining from that complex type of data in the some of the relational database repositories, as well as on the data marts, data lakes, and as well as on the some of the repositories. Now we will talk about what is multidimensional analysis. So multidimensional analysis is nothing but the analysis that is having the 3D type of analysis of any type of data. So a major limitation of the many commercial types data warehouses and as well as related tools that is having the multidimensional fetching, multidimensional analysis. So for that, that will have the restriction on the allowable data types. So what are the data types that we can use on that, how we can process the data? So that will be the question, how to process that data. So the data can be in the form of 3D, 4D, 5D, 6D. So that type of data, how we are going to analyze in a multidimensional manner. So the data, for that we have to capture, we have to tell about the, we have to know about the, what are the dimensions of that data and what are the different measures to know that data. So most data cube implementations will be there. What is data cube? We have seen in the earlier slides. So the data cube is nothing but that is having the 3D view of that particular data object. So the most of the data cube implementation, that is confining the dimension to aggregate that non-numeric data and as well as the measures to simple aggregate that type of values, that type of numerical values. So to introduce the data mining and multidimensional data analysis for the complex objects, here we are using the data objects. So to introduce that data mining and multidimensional data to analyze the data for the complex objects, this section, in this section we are going to examine how to perform generalization, how to generalize that data in the form of we can use that data, we can have the knowledge of that data, we can have the hierarchy of data. So that on that we have to perform generalization as well as on the complex structured object and construct the object cube for OLAP. So we will have the OLAP tools to do that capturing of that different cubes. So and after that we have to mine that data objects into to store in the form of databases. So that was the way how we are going to see how the multidimensional view of the data we can have to see about the patterns and as well as for the data types. So descriptive mining of complex data objects. Here we are taking the complex data objects. So what will be the descriptive mining of that? So the storage and access of that complex structured data we have studied in the object. So here we will take the example of descriptive mining of complex data objects. So what is the descriptive mining? So that is having the description of all the data. So here we are taking the complex data objects. So we will see the descriptive mining of that particular data object. So the storage and we can say how we are going to access that complex structured data that we have studied in object-relational and object-oriented database systems. But these are the system that is going to organize, that are going to store that huge amount of data objects particularly into the form of classes. So the classes which we will have in turn to organize into classes as well as in subclasses hierarchy. So the concept hierarchy will be there to store that complex data objects into the form of classes and subclasses. So this is the view how we are going to see each of the data objects. So each of the data objects into one class is going to associate with it will have the object classifier, object identifier. Now that will also have the set of attribute that can contain that data structure, the set or list valued data, and as well as the data composition and hierarchy of data. In that, multimedia data can also be there. So that will be the set of attribute. Now in that the set of methods will be there. So the set of methods are nothing but that is going to specify the routine and rules associated with the per every class with the data object. So that was these are the three things will be there for the each of the object in a class. So to know about the generalization and induction, these are the two methods in the object relational and as well as the object oriented databases. It is very, very important to study how to generalize the data, how to generalize structured data, how to generalize that unstructured data. So we have to generalize that data to see that data into the form of hierarchy. So we can have the multidimensional data. From that we can have the multidimensional view of that data into the form of data cubes, and then we are going to analyze that data for why data mining, because our goal is to do the data mining for that particular data. So that we are working on the data complex data objects. So now we will take the generalization of structured data. So an important feature is there for the object relational and as well as the object oriented databases, that is having the capability for storing the data, to accessing that data as well as the modeling that data. So that will have the complex structured format. So in that we can say that will have the list value, that will have the set valued data, and that will having the nested structured. So the data will not have the in the easy format, that will have the subclasses and nested classes. So now we are going to take the generalization of set valued attributes. So what is set valued attribute? Set valued attribute is nothing but that is having the each value in the set in the form of set. So the set valued attribute, they can have the homogeneous in feature and that can have the heterogeneous in feature. So a set valued data that can be generalized for the generalization of each of value in the set into is corresponding the higher level concepts. So that is having the higher level concept hierarchy. And another thing that is having the derivation of general behavior of that particular set, such as the number of element and that particular set. And third thing, that will have the weighted average. So weighted average will be there to know about that numerical data, to know about that complex data. So however, going to apply the generalization technique for to operate the operator the explore the alternative generalization paths for the minimum generalization. So that will have going to have the weighted average of that particular data. So in this case, we can have the result in the form of generalization is heterogeneous set. So there will have the heterogeneous set for that. Now we will take the set valued attribute. So what is set valued attribute? That will have to generalize into the form of set valued, we can say the single valued attribute. So that those are the attribute that is having the single valued, having the set value, that is called as a set valued attribute. So the set valued, single valued attribute, we can have generalized into the form of set values attribute if the value form a lattice. So if it will have the hierarchy in the form of, it will have the generalization, then it will go into the set valued attribute. So for the hierarchy, for the generalization, how we are going to check, how we are going to understand for the different paths. So it is having the some of the path for to do the hierarchical representation. Suppose if we will take an example, suppose hobby is equal to, and that is having the tennis, all of the type of sports we are having, tennis, hockey, checkmate, violin, and other type of games that can have generalized into the form of sports as well as with the music, video games. So in that there can have the generalization, there can have the concept hierarchy, and the sports type of things, it will go into the sports classes. So in the sport class, the tennis, hockey, chess, etc. will go. In the music, the music type of the classes will go, and in the video games, these type of video games will go in that particular hierarchy. So that will have the generalization of each of the particular classes. Now for the further generalization, we can have the generalized set valued attribute. So that should have follow to generalization path for the each and every value for that set. What are the values are there in particular one set that is going to check, that is going to show the hierarchy of particular values. So for the further generalization, we can have the generalized set valued attributes. So a set list valued and sequence valued attributes can be generalized into the form of similar. So how we are going, we have viewed the list valued and other type of valued attributes. The same manner we are going to generalize these list valued and sequence valued attribute. So the set valued attribute that will have except the order of the elements in the sequence should be observed in the generalization. So here only the one thing will be there, we have to check about the order of elements. Each value in the list can be generalized into its corresponding, its relative higher level concept. So the concept hierarchy will go with the higher order. The higher level will be there, that will come first, then the lower, then lower. So in that hierarchy, we will follow the generalization things. Alternatively, if we can say the list can be generalized according to its general behavior. So if one example is there, length of the list is there, the type of the further list elements are there, the value range are there, the average weight is there, some numerical data is there. So that will have the particular order in how we are going to show the generalization, how it is going to represent the concept hierarchy. So that will have the particular order in what I have said, the list elements, the value range will be there, the weighted average will be there. So in that we have to drop the unimportant element from the list. So if we are going to generalize the things, we have to understand about the each and every values in the list. If that is not useful, we have to drop that elements. A list can have the generalization into the list, set and single value. So that is related to the generalization when we are going to when we are going to edit that particular list. Now we can have the complex structured value attribute, if that type of attribute will be there, that have contain the sets that can have the tuples, that can have the list, tree and records. So in these type of values, their combinations can be there. So where one structure can be nested to the another level. So if we are going to list these type of attributes, we have to know about the labels of every attribute. In general, we can say that structured value attributes can be generalized into the several ways. That can have the that is having the 4 formats that can have generalized into the each attribute in the structure, while it is we are going to maintain the shape of the structure. So the shape of the structure will be there. In second form, the flattening of the structure will be there, and we are going to generalize that particular flattening structure. Next, we are going to summarize the low level structure by high level concept. We can say we are going to aggregate that structures. So lower level to higher level. The fourth form will be there to return the type. We can see the overview of the structure. So here particularly the type of the value will have returned in the form of structure. Now we will see the aggregation and approximation in the spatial and multimedia data. In that we will also see how to generalize that multimedia and spatial data, and how to aggregate that data and approximate that data. So the terms aggregation and approximation should be considered an important means of generalization. That is another form of generalization. These two words for use for only for generalization, but which is having the especially useful generalization attribute, as well as with the larger amount of values, that is having the complex structures with the spatial and multimedia data. For example, we would like to generalize detailed geographical points. If there are geographical points into clustered regions, that is having the regions that is having in the form of business, in the form of residential, industrial and agriculture area according to the land usage. So that type of data generalization, how we are going to take, we will see. Such type of generalization often require the merge of a geographical area. So for that, to generalize that type of data, we have first for the data mining, we have to generalize that data into the form of, we have to merge that geographical lands, geographical area. So there are some operators to do that. The spatial operators are there that will have the operations on that to merge that geographical lands area, such as spatial union and such as spatial clustering methods. So first we have to merge that particular set of geographical lands. Then the aggregation will be have for the spatial merge. If we are having the spatial merge, it is necessary to not only merge the region of similar type within the same general class, but also we have to compute the what is the total area is there, what is the average density of that particular land is there, and any other type of functions are there. So while we have to calculate these, also we have to ignore some scattered regions. If there in that particular graph some scattered regions are there, that is not useful. We have to ignore, we have to exclude that particular regions. And if it is having the unimportant study, we have to not take in for that particular merging. So we only have to merge that spatial geographical images for the specific regions and its general classes, that is having the total area, average density, as well as the aggregate functions related to that particular functions. For the other spatial operators, if that is having the spatial union that we have applied on that particular spatial merging, that will have the spatial overlapping and spatial interaction. So that can have requirement the merging of scattered small region values or points. So that means that in that we have to aggregate, the operators have to aggregate the scattered small regions into large. That can have the clustered regions, that can have the merging of particular areas. So in that can also have used the particular spatial aggregation approximation for that generalization operators. So that will be easy to do that particular generalization. These are the two techniques we can also apply for the spatial operators. For example, suppose we have the different piece of land for the various purposes of agriculture use. So for that, such as the planting of vegetable, grains and fruits, so these type of pieces can be merged into one piece, into one land. So that can have the aggregation into the one large piece of agriculture land into the spatial merging. So that on that we will use the spatial operators, spatial operations of that particular approximation and generalization. That however such a point of agricultural land can also contain some of the times highway road can be there, houses can be there, small stores can be there. So in that we have to exclude these of the parts. If the majority of land is used for the agriculture, the scattered regions for other purposes can be ignored. So that I have said, these type of particular points can have ignored, and the whole region can be claimed as a agriculture region for the approximation and aggregation of that particular we can say land. So we can do the generalization like this. Now a multimedia database we will take. So a multimedia database may contain the complex text, it can have the graphic, it can have the images, it can have the video segment, fragmentation, it can have the maps, voice, music and other forms of audio video information. So multimedia data will be particularly that is going to stored as a sequence of byte. So what we can say, the multimedia database having the sequence of bytes with variable lengths as well as the segment of data are linked together. So that will have the index for the multimedia way to referencing the each of the we can say images as well as the type of that particular data. Now the recognition and extraction, and these are the two features are there for two general patterns of the such data to perform the generalization and multimedia data. So these are the two we can say the functions features are there to apply for the generalization. In general, we can say it is a challenging task to apply these of the two functions features on that to generalize spatial data as well as the multimedia data. So if we are going to club these are the spatial data and multimedia data together, so that will have the challenging task to do that in order to extract the interesting knowledge implicitly stored in that particular data. So the technologies are there that is having to develop into the spatial databases as well as in the multimedia databases, that is having the spatial data accessing and analyzing techniques. So some techniques are there to do that particular aggregation of these particular multimedia and spatial data, and also the content-based images retrieval and as well as the multimedia indexing methods are there. So that should have integrated at one place for the data generalization and data mining techniques to achieve the satisfactory results. So these are the some techniques we can apply for the spatial and multimedia databases if we are going to do the aggregation and generalization together. Suppose example is there. Here we are having the plan mining of the dividation and conquer method. So the plan is there, a variable sequence of actions will be there. For example, the variable sequence of actions, what is this? It is having the travel, that is having the hierarchy actually, that is having the hierarchy. In travel, we can have the traveler, that is having the story, that is having the traveler, that is having the departure, arrival D time, arrival time, and airline price and seats. So these are the variable sequence of actions at one place together. So that will call as a plan. What is plan mining? So extraction of important and significant sequential patterns from that plan base. Plan base is particularly a large collection of plans. So the particularly variable sequence of actions will be called as plan base, that is having the huge collection of that particular plans in one place. So what is plan mining? That is having the extraction of these of the generalized patterns from that. So for example, if we are going to discover the travel pattern for any flight database, if any flight sequence is there, any flight structure is there, if you are going to discover that pattern, so we have to find the significant pattern from that, from the sequences of actions. So how we are going to, first we have to first we have to understand about the variable sequence of actions in the form of plan, and then we can have the significant patterns from that, as well as we can have the repair of automobiles in that also. So that will have contain these all related patterns on that. The method we can apply for that, the attribute oriented indexing, that is having the sequence data. So the generalized travel plan can have the small and big and small. This method can have. Although on that we can apply the divide and conquer method. In that we can have mine characteristics of each of the subsequence. So in that in the earlier method we were doing the sequence planning, sequence accessing. In that we can have divide and conquer. We can have the subsequence also. For example, if same airline is there, that is a big airline and that is having the plane as a same airline, and small big airline is there that is having the nearby region. So like that we can have the aggregation on that particular planes. This is the travel database, and for that we can have the plan mining. So that is the particular database that is having the some columns that is having the plan number, action number, what is the departure of that particular flight, that is what is the departure time of that particular plan, and that is what is the arrival and arrival time, and what is the airline is there, what are the different type of airline is there. Although that is having the in airport info table. So in airport info table, that is having the airport code particularly related to different airports, that is having the city related, the state and region, and airport size related. So that type of data will have the in the airport info table. So for that, we can also view in that type of data into the form of multidimensional analysis. If what will be the strategy to do that? The strategy will be there. We have to generalize that plane base into the p different directions. So what are the directions are there? Here we have taken the multidimensional model of that plane base. So it is having the three-dimensional, 3 x, y, and z. That the x dimension is having the location, the y is having the airport size, and z is having the airline type. So the p different directions can be there for generalize the p plan basis. Next step can have the look for the sequential pattern. So what are the sequential patterns for the generalized planes? So we have to find out that, and then we have to derive the high level plans. So what are the high level plans related to that? So we can have the concept hierarchy for that. So like that, we can have the multidimensional analysis for that plane base. So in that, we can see here in the location part, we are having the city, state, and region. So that is having the lower to upper, that is having the lower to upper dimensions of that particular location. In airport size, that is having the passengers number and category. So like that there will have the different sequences, that there will have the sequence patterns. In that airlines, if you will see, there can have the partnership, and that can have the direct that particular company. So in that, we can see here in the left side, we can have the concept hierarchy for if we are going up, that will have the more detailed generalization and the concept hierarchy for that particular multidimensional model. So that was all about that about the multidimensional analysis for the complex data. What in that we have taken the spatial data, and we will understand about the multimedia data as well as the structured data. So that was all about the today's class. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.